meeting is being recorded.
Got it? Yeah. They're seeing it. He was in that class.
And then Lisa, you'll be keeping care of all of the questions and that.
Yeah, I will track all the questions.
Okay, great. And then we'll review them at the end of the presentation.
Correct.
Perfect.
All right, it's 10 o'clock. Hello, everyone. I'm Lisa Weir with TT Mac. I wanted to thank you for attending this month's Tile Tech Talk. For those of you that require a CEU self-reporting certificate, can you please put your name in the chat section? And I'll get that to you as soon as the Tech Talk is over. Also, if you have any questions at the end of the presentation, we will handle those. So please put them in the chat section and I'll keep track of them. I'd like to introduce you to Vincent Roy of Polycor and thank him for all his time and expertise. Vincent Roy is the regional sales manager with Polycor's architectural sales team. He's been sharing his passion for stone with the construction industry for over 20 years, a skill set he acquired thanks to a 3-year tenure as an estimator and project manager at Polycor's head office. Vincent, off to you.
Okay, well, greetings everybody, and thanks a lot for showing up for this tech talk. So we're going to be talking about stone tiles, and mostly stone tiles that the type of stones that I'm more commonly working with. So we'd be talking about granite, limestone, marble, and soapstone also. And just talking about how the fabrication is done and how the fabrication processing, a bit of the tolerances, but nothing with regards to installation at all. There's probably a lot of other people that are much better qualified than I am for installation. So that said, just a quick synopsis of what Polycor is up to. So Polycor was founded in 1987 in Quebec City, and it was solely a quarry, the polychrome quarry, which was for like an earth-colored stone. They quickly realized that having a cutting facility would greatly help their increase in volume in that. So that said, they bought into a company called Granite Bussière, and basically went on to a buying spree. So they bought a tile company, a landscaping company, and now we purchased Rock of Ages, Swenson Granite, which is more into the retail stores. And our latest acquisition was Indiana Limestone Corporation, which was done last year. So here's a quick video showing a bit of our projection, the company here.
Like people, natural stone is unique. Every piece has its own shade, is shaped by the place from where it came, and by what it has experienced over time. From our hometown's most noteworthy landmarks to the backyards where we gather with our families, natural stone is everywhere. It has played a major role in the legacy of our country. America was built with natural stone, and our communities continue to benefit from it today. From coast to coast, our locally quarried stones have stood the test of time, and their quality is not only proven, it's a promise. From Indiana to Georgia, from New England to Oklahoma, American stone is nature's gift. Our stone is from the earth and for the earth, just as nature intended it to be. Let us take pride in our surroundings, our origins, our history, rooted in stone.
Okay, so we're going to start this presentation. So it's given by the TTMAC Tech Talk, and we're going to be talking about stone tiles. So what is a tile? So as per Wikipedia, they are mass-produced stone tiles with uniform width and length. So that's more or less true, but mostly tiles are below 20 millimeters in thickness, and usually within the 750 width, 1500 millimeters in length. Also, the more common materials that are used for stone tiles would be granite, marble, limestone, soapstone. And there's also a lot of slate tiles, sandstone, as well as travertine. We're not getting too much into those just because I'm not all that familiar with those types of processing and those types of materials. So tiles are sawn on both sides, and then they have a polished finish or several other different finishes that we're going to look into. We're going to review further down in the presentation. They're all of a uniform thickness, which is sometimes true, sometimes not all that true. So we're going to get into that also and see exactly why a uniform thickness tile is God's gift from heaven for the stone installers. And then the floor tiles, well, they're commonly set on a mortar, sand, and cement with latex additive to have a good bind on from the stone onto the substrate. And then the joint spaces are filled with a grout, basically. So we're going to get into just seeing how the stone is extracted here.
Extract the granite from the ground. We start by drilling what we call pilot holes. These pilot holes will become the edges of our block and determine its length, width, and depth. Then we use diamond wire saws, which are extremely long plasticized wires with metal junctions called annuli, fitted with crushed diamonds.
I don't want to. I'm innocent.
Why we're using diamonds is because diamond is the hardest naturally occurring substance on Earth, allowing it with sufficient friction to cut through granite. To obtain the necessary friction, the wire is wrapped around a series of idler wheels powered by a motor. making the wire travel at around 3,937 feet per minute. The engine then slowly moves back along a track, pulling the wire deeper in the stone block until the desired depth, length, or height is achieved. Then we use the same method of wire sawing to cut the bottom of the block as well. Once the bottom cut has been made, one of two techniques is used to tip the blocks down so that the loader can carry them away. One is by attaching a long steel arm to a wheel loader that pushes the block until it tips forward. But to eliminate the chances of these gigantic blocks breaking when they strike the granite beneath, we pile up dust and dirt under the falling stone to absorb the impact. The other clever option utilizes a simple bag, similar to an ordinary Ziploc bag, but much larger and made from metal. This bag is inserted in the cut created by the wire saw and then filled with water or air. The expanding bag then generates enough pressure on the walls to tip the block. We then have a large block free from the larger block around which we saw it. We continue cutting the big block into these smaller blocks, much like slicing a loaf of bread, but resulting in slices that may weigh as much as 25 tons. These blocks then travel to a building to be cut into thinner pieces called slabs that are then sent to the factory where they begin their creative transformation.
So that's how we extract granite and marble from the mountain. Now this is another way of extracting some of the softer stones. So some of the limestone was extracted with this type of enormous chainsaw. So that chainsaw basically digs into the mountain or into a block, and we'll cut it into either slabs or into blocks, slabs or various size blocks. So we've talked about the ways of extracting marble, granite, and limestone. Now we're going to talk about the different types of stone. So granite, limestone, marble, and soapstone. So and how they're used in a tile format. So granites, as you can see here, several numerous colors of granite, and as you can see also, there's a different sort of grain structure sizes on the stone. So here would be a fairly fine grain structure, and when you go towards the middle, you can see a larger grain structure also. Marble, a bit similar to granite, but more in a wavy pattern, and then you also have the limestones, which are a more muted color, and mostly in the earth tones with some darker colors also. And then once again there's you can't see too much of a grain structure, but you'll mostly find features like different sort of fossils, shells, and different sort of marine animals within the limestone, which is quite a nice feature for the stone now. And then there's soapstone also, which is basically a compressed talc. We're not seeing too much soapstone as tiles. It just has that sort of soapstone name, which seems to render it as a slippery stone, which is effectively the opposite of that there. But it's a nice stone with a nice touchy feel to it. So the stone type, so we get into the granite. So it's an igneous stone, and it's probably the most versatile and durable stones for tiles. It can accommodate a very heavy pedestrian and harsh conditions. So when I say heavy pedestrian, we would be talking about the entrances to airports, public buildings, shopping malls, and transit stations as well. So they have a lot of traffic there. People are coming in from outside with a lot of dirt, muck, grime, salt, and all sorts of different stuff on their feet. So granite is the most durable stone for that type of application. And then you get into the limestones, which is a sedimentary stone. So it's less dense than granite, so not as hard as a granite, but there are some that are very hard. So we are separating the limestone into two categories. One of them, the more dense one, would be the dolomitic limestone. Aramosa, Algonquin are some of them that come to mind now. And then the less dense limestones, which would be the Indiana limestone. So not all limestones are suitable for heavy pedestrian traffic since they are a softer stone and they have a tendency to wear out. They do lose their finishes also. So ideally for heavy traffic and when you're using a limestone, ideally go towards dolomitic limestone. So as I said, Aramosa, Algonquin. And then there's several other foreign materials, foreign dolomitic limestones. Then we get into the other type of stone, which is the marble, so a metamorphic stone. So density is quite similar to that of a granite, of a dolomitic limestone, so fairly dense, suitable for moderate to heavy pedestrian use as well. But this stone here is a bit less keen on salts and de-icing agents and moisture. So tends to weather a bit quicker and all that. So maybe not the ideal stone for the entrance of I don't know, a big train station or subway station where they tend to get a lot of wear and tear, as well as a lot of muck and grime that's trampled in from outside. And then so we've gone through the different types of stone. Now we're going to talk about the different finishes that are applied onto those stones. So we mentioned previously the density of the stone, so the hardness of the stone. So the harder the stone, the more of a polished finish you can apply to that stone, or you can put onto the stone. So polish is a high gloss finish, mostly used on granite, marble, and on some limestones. It's commonly known that on marble and limestones, the polish finish tends to fade away and end up looking like a honed finish. This is more on an exterior application where you'll see this. So usually the polish on a marble will stay on an interior application. Honed, very similar to polish, but instead of having that reflective look on the stone, it just it sort of goes to a more of a muted or a matte finish. Now, similar to the honed, you have the antique or brushed. So all depending on the trade names that are used, some people will call it an antique finish, some people will call it a brushed finish. And it's merely very similar to a honed finish, but instead of having the finishing of the honed finish being done with a brick, it's done with a diamond tipped bristles. And I'll show you further down in the presentation the pictures of those types of pads that are used to do the antique finish. So it gives you a slightly textured finish with, you know, a few depression, few millimeters at most there. So it's just, instead of being a very flat surface, very slightly textured. Then you have the thermal flamed plasma. So thermal flame plasma, it's all pretty well the same thing. It's the action of heating the surface of the stone until the quartz and the feldspar, they sort of pop under a certain heat. They sort of pop open, and then creating that coarse surface that you need to have this anti-slip coefficient. We're going to get into that further down in the presentation also. So not all stones can accommodate that flaming process. So you need to have a certain amount of quartz and feldspar in the stone. So most of them would be flame finish would be used on the granite. There are certain occasions in limestone, particularly some of the French limestones, that you can have a flamed finish on them. So if we're working with either a limestone or a marble and you need that coarse surface treatment, then we have what we call the sandblast, which is basically just the sandblast applied over the surface of the stone and gives you that slip resistance. So I'm just going to go back one slide here and show you the difference. So we're talking about one stone here in the picture. Complete on the right side is the polish finish, same stone again, honed finish, and then flame finish. So you can see out of one stone, you're getting almost 3 different shades, just playing around with the finishes. And then the last finish that's quite commonly used would be the water jet. So water jet's a very high pressure water jet. We're talking about between 20 to 30,000 PSIs that goes over the surface of the stone and just breaks down the surface to about a couple millimeters in depth and exposes the rich color and texture of the stone. So advantage of this water jet is we're just using a very high pressure water jet. So there's no propane gas or sand or anything like that that's used. It's a very natural finish on the stone. It does have some downsides on it, as it's instead of being a bumpy surface, it's a bit more of a pitted surface. So it will trap in a bit of muck and grime also. So on this picture here, we can see the top portion is a sandblast. So this is a black granite. And then the bottom portion is the water jets. You can see a very, very, very noticeable difference between both finishes, exactly the same stone, but quite a different finish. And they both have similar coefficient of friction for the slip coefficient. So we've talked about the different types of stone, how we extract that stone, those stones from the mountain, the different types of finishes that are applied to the stone. Now we're going to start talking into the processing of the stone. So for the tiles, usually tiles are fairly small pieces, as I said, up to 4 to 5 feet in length, so 1,200 to 1,500 millimeters in length, and fairly narrow. So commonly are used smaller blocks to go from a block into the tiles. So small blocks being about 1,200 by 1,200 by 1,200, so 4 feet by 4 feet by 4 feet. And those blocks are installed on a block cutter. So we can see at the bottom of the picture here, the block is right there. This equipment here would be what we call the block cutter, which is installed on a bridge saw. And these small pieces here are the strips. So let's say we set up the saw to have a 12.5 millimeter thick tile. So these blades here will be spaced at exactly 12.5 millimeters. They're turning in a rotating fashion and then go down onto the top of the block and cut the block into thicknesses of 12.5 millimeters. Now that blade goes down to a certain depth, and that depth is going to dictate the height of the stone. So let's say it goes down to 600 millimeters in depth. You're going to see this blade here go down into the stone 600 millimeters in depth. Once we have all that cut into there, all the strips are still solidly anchored to the block. Then we have what we call a horizontal blade cutter. So this one here is right here, and it'll cut the strips and loosen them from the block, creating strips that are now 600 millimeters in height and 12.5 millimeters in thickness. So those strips are sawn finish on both sides, and then they're sent to another piece of equipment, which is called the calibration. So we mentioned that tiles are a uniform thickness. So to get that uniform thickness, when we're doing in the sawing process, sawing wheels are not always 100% precise. So we have a conveyor belt that will sort of grind down the back of the stone and give it that constant thickness. So very important to have that constant thickness on the edges of the stone, the middle of the stone, and on the entire perimeter. So so that conveyor belt will grind down the stone to the exact thickness. Then after that, we have the various finishing process, either polished, honed, antique, flamed, and water jet. So those finishes are applied to the stone. Then we have what we call the rectification process, which cuts the strips from one end to the other, making them a perfectly rectangular shaped stone. And then after that, we have these multiple blades here, which can be moved all depending on the size of the stone. So bear in mind that we had a strip that was 12.5 millimeters in thickness, 600 millimeters wide, and now we have to cut it to the exact length. So it could be anywhere from 200 millimeters all the way up to 600 millimeters. Now these sort of parameters and sizing are based on the equipment that we're using. There are different tile companies that have different sizes also. So all depending on who you're getting the stone from, minimum or maximum sizes are always determined by the type of equipment. So once the rectification process has been done, then we have to do the bevels on the perimeter of the tile. So a bevel, you can order tiles without bevels. Ideally, they come with a bevel, micro bevel, which is a 1 millimeter, and all the way up to about 4 millimeters for the bevels. The purpose of the bevel is to prevent chipping of the stone while we're handling it and while it's being installed, as well as an edge of a stone with no bevel is very, very, very sharp, almost as sharp as glass. So it prevents, it's more of a safety measure also doing the bevels on the tiles. Okay, so now here is actually, this here is the bevel machine that'll do the bevel on the entire perimeter tile.
Ticket. Afasta o ticket devagarinho, vou uma mão.
Okay, so and then as I mentioned earlier on, all depending on the type of equipment, stone tiles can go from a minimum thickness of about 10 millimeters, which would be 3/8 of an inch, all the way up to 20 millimeters, and can even go beyond that. Depending on the type of stone, some stones are more fragile than others, so you can't go very long or wide with them. So once again, dimensions and thicknesses are depending on the equipment as well as the type of stone used. So as I mentioned, these production methods are based on the equipment that we use here, but there's a lot of other North American tile companies or European or foreign tile companies that may have different dimensions that they could offer. So I would say, as a good practice, always refer to the person that's supplying the stone and see what their capabilities are and what their equipment can, what size their equipment can process. So we talked about, yes? Sorry. Okay, so we talked about tolerances, and then tolerances, as I said, there's the industry tolerances governed by the TTMAC and other stone institutes. There's also the tolerances that are governed by the equipment that's used. So usually the thickness is plus minus 0.5 millimeters, squareness plus or minus a millimeter, so that's from left to right, and then dimensional width would be plus or minus a millimeter to 1.5 millimeters. So now we've determined how to extract the stone, how to process it, and now we're going to be looking at the range review, because pretty well every stone has its own features. So features being could be a blotch here, could be some veining. There's all sorts of different features that come into stone. So it's very important to get some samples of the stone that you'll be specifying or you'll be working with, and using several samples also. So usually the way to get those samples is not just 4 pieces coming from the same block or from the same strip, but it's to get 4 to 6 pieces that commonly come from several blocks, so you can get a very good range of what the stone is actually showing. So in your range of 4 to 6 tiles, you could have either a shade difference, there could be some inclusions like we see here, there could be veining, and then all depending on the type of stone that you're working with, you could have sort of different features have to be contended with. Bear in mind that any features that are refused or are not basically considered acceptable, well, it's considered as waste, and we take up more stone to achieve or to get to that final product of a very pure and nice tile there. So that's why range samples are very, very important, and to a certain extent they shall dictate the price per square foot of the stone also. So here we have a limestone. So ideally the range should be determined prior to issuing the tender, so all bidders know exactly what they're expecting. So when the project comes out for tender and they're specifying a certain type of limestone or granite, if there's no range that is being predetermined, then ideally you're going to get what we call a quarry range. So whatever comes out of the quarry is processed, is packaged, and is sent to the customer. Sometimes you'll have a few surprises. As you can see here, this is a marble flurry cut, and you can see that within the same, with this range here has quite a few different shades in the stone, from a darker to a lighter, as well as some different sort of veining. So this here is what we call a quarry range. So it's exactly what comes out of the quarry as processed. Now this range can be tightened up to use probably only the lighter shades, medium shades, or the darker shades. Once again, this is something that ideally should be specified at time of tender, but rarely does that happen. So you can imagine that it comes, there's some very interesting discussions once the range is proposed after the time of tender. So just getting back to the range, all depending on the type of stone. Some stones will require more pieces in the range. So limestones and marble usually have a wider range than a granite. Granites usually are fairly stable products, so they don't come in too many, don't have too many features. They do have a few shade difference here and there, or some veining and a few inclusions. But apart from that, granite is a fairly consistent material. Limestones and marbles are a bit different, as you can see within this one here. So once the range has been more or less determined, there's a few other stuff that has to be looked into, namely some of the ASTM data with regards to the slip resistance. So ASTM standards. So there are a few ASTM standards that are very important. Most of them, when we're talking about ASTM C615 for granite, that'll encompass 4 or 5 tests: density, flexural strength, modulus of rupture, and compressive. Same thing for the limestone also. One ASTM standard that's very important for interior tiles is the DCOF and SCOF. So dynamic coefficient of friction and static coefficient of friction. So dynamic coefficient of friction is when the person is moving on the stone, and static is when the person is just standing on the stone. So there are minimum values for stones for an interior, and each stone has to be tested, and each finish has to be tested as well. So those are very, very important testing that has to be done. Not a very expensive test. Usually takes a couple of weeks at most to do this testing, and usually any stone supplier or any tile fabricator should have this information on hand. And if they don't have it, it can be easily done through testing. So as I said, testing is I believe it's below $1,000 for 3 or 4 tests on different finishes. And as I mentioned, you can have a white marble with a polished finish. Your slip resistance will be different than a honed finish, than an antique finish, and a flamed water jet or sandblast. So each finish has to have its own tests being done. There's also the ASTM C1353. So that there is going to evaluate how long your coefficient of friction remains on the stone. So it's all nice to specify a stone with a certain coefficient of friction, but if that coefficient of friction gradually goes away with wear and tear, you end up with a slippery stone, and it sort of defies the purpose of having those testing. So very important to have that C1353, which will determine how long the DCOF or the SCOF will last on the stone. So there's also cutting direction that will sort of alter to a certain extent the look of the stone. So we can see the Picasso granite here, which is a flurry cut. Unfortunately, we're missing a bit of the lettering right here, but it should be flurry cut and then vein cut. So a flurry cut is when the block is cut parallel to the bed. Vein cut is when the block is cut perpendicular to the bed. So as we can see on this picture here, the cutting direction, it can affect the visual of the stone as well as the shade. So this stone here, exactly the same stone from the same block, same finish as well, cut in one direction versus another direction. So you can see that the grain structure is slightly stretched out on the vein cut versus the flurry cut, which is a more dense grain structure. Same thing for the shade as well. The shade is slightly altered with a different cutting direction. So on most granites with a medium to fine grain structure, the structural integrity of the stone, whether it's vein cut or flurry cut, shall not be affected at all. As for some other stones, marble and limestone, quite different. So we're going to look at that marble and limestones cut in the different directions here. So at the top here, this is a St. Clair marble, flurry cut on the left, vein cut on the right. So here we can see that the shade is fairly close to each other, but the overall appearance is much different here on the top one. Same thing for the St. Pierre, which is a limestone. Same thing there. So you can see the right-hand side, which is a vein cut, left-hand side flurry cut. So with regards to structural or flexural strength, the flurry cut has much more flexural strength than a vein cut. Obviously, you can see why, just because of the veining in the stone. As soon as there's a bit of flexural strength on that, the stone has weak points in that vein cut there, contrary to the flurry cut, where the stone is much more structurally solid in that view. So for flooring, it's not all that important, the direction of the stone for the structural strength of the stone, since the stone is fully bonded on 100% or hopefully 100% of the back of the stone. So it's not too important the direction on the flooring. If you're using tiles on a pedestal system, that is completely different, and I would not go down that path with a vein cut on a pedestal system. So apart from, as I said, the aesthetics of the stone, there's not a whole lot of other stuff to mention vein cut versus flurry cut, unless you go outside. Now, not a whole lot of tiles are installed outside, but if ever they are installed outside, vein cut is definitely not the way to go, as those horizontal veining shall gradually open up, water will get in there, freeze thaw, and then just the stone will gradually disintegrate, and within a few years actually. So it's very quick. So that's very important to understand the cutting direction and use it in the right applications. So there's also a few marbles also that all depending on the cutting direction, also you can the structural the flexural strength, sorry about that, the flexural strength of the stone shall be impacted based on that cutting direction. So once again, flurry cut is the more sturdy stone for flexural strength versus the vein cut. So a lot of things that should take into account when we're specifying stone. So we have the oxidation of the stone. So mostly some of the lighter colored granites, so green colored, gold colored stones, once they're extracted from the quarry and they start drying up, there's a certain oxidation that happens on the stone. That oxidation shall alter the color of the stone. So something when you are reviewing stone samples of some of those colors, as I said, it's mostly the lighter green colored stones, mostly granites, green colored, gold colored. They have a certain amount of oxidation that's done once they've been extracted and once they're dried also. So color of the stone can drastically change from a stone that has not oxidized to a stone that has oxidized. Excuse me. So another thing that's very important is to matching existing stones. So when there's an addition to a job, a project, to try and match those stones. So usually it's quite easy to match them when you're working with a granite that's fairly homogeneous in appearance. Some limestones also are quite easy to match existings, but it's often a fairly difficult task on some of the more intricate stones. And then matching existing can be also altered by sealers and other products that are applied to the stone. So that's something to be very cautious about, is the different types of sealers, color enhancers, and different products that are applied to the stone, either once it's installed or after it's been produced and ready to install. So I'm not very fluent with sealers, but they are used. They are there for a purpose, and some of them are very good. Some of them, have to be have to do a good due diligence on the different types of sealers and why they want to be used. We have seen some sealers that'll enhance the color of the stone. And then when it comes to replacing some stones or getting some stones that are exactly the same as that one, it's almost impossible to match because they've had a sealer applied to them. So sometimes the ideal way is to strip that sealer from the stone with different sort of chemical agents and then reseal the stone with the new stone in place. Another thing to take into account is the moisture content. So some stones are okay with the moisture content, some stones are not. So we're talking about tiles that will go into either reflective pools or pools altogether. So very important to get all the ASTM data on the absorption rate of the stone. Also, some stones will absorb a fair amount, but it'll evaporate very fast, very fast as well. So there, once again, to do your due diligence on that and get all of the ASTM mumble jumble that pertains to the absorption of the stone. Also bowing. So this is something that we see mostly on darker colored granites and also on a flamed finish. So very important if you're specifying a nice black tile, fairly narrow and fairly long with a flamed finish, flamed plasma or thermal finish. The action of heating the stone up on a thin stone, that heat that's been encompassed in the stone has to go somewhere, and often the stone will bow. So very important to look into that and to see how that could affect the overall appearance of the project. Alternately, instead of using a flame finish on those darker stones that have a tendency to bow, that's when you would probably look more into a sandblast finish, or maybe even a water jet finish that does not heat up the stone, but still gives you that that sort of it gives you that slip resistance. Sorry. And then also we did discuss bevels and how that will affect the joint size. So obviously, if you give a generous bevel, so 4 millimeters bevel, that's going to increase your joint size as well, since the mortar not the mortar, but the grout goes all the way up to the finished the height of the stone, hiding part of the bevel, but sort of increasing that size of the joint. So something very important to look into also. Joint size is also very important because stone does shrink and expand with the thermal contraction. Not something to take too much into account on an interior application, but should be taken into account on an exterior application, and particularly in an area where it's very sunny. And a dark stone also. Dark stones have a tendency to absorb much more heat and expand and retract more as well. And then, as I mentioned earlier on, the sealers and some of the other products that are used to enhance the stone appearance and the performances. I have heard of different sort of sealers that'll give you a bit more slip resistance on the stone. So those are things that have to be verified, tested, and get the proper documentation on that, so that you don't end up with all sorts of different sort of fiascos that we've seen in the on different tiles and different objects around the place there. So this here pretty well wraps up the presentation. I feel like I rambled through that one pretty quickly there, but hopefully it's been quite intuitive for you.
If any of you have any questions, now's your chance to ask them. I have a request for 4 certificates. I just want to make sure I'm not missing anybody. Jennifer Reynolds, Victor Suen, Louise Webb, and Chantal Roy. If there's anybody else, just throw your name in the chats. Now's your chance if you have any questions. You're welcome to unmute and ask them if you do. If not, Oh, I got another Christina. I have Christina Heath and Melissa Mass for certificates as well. And Henry Tufts. Yes, the slides will be available. We are going to post it to our YouTube channel.
So yeah, I'll be sharing this presentation, and I'll add a few items with regards to some of the ASTM specifications, ASTM test data.
Great. Well, it looks like, Vince, you covered it all. Nobody has any questions.
Okay, well, if ever there are any, I'm sure they'll be able to reach me either through email or different methods there. So, well, thanks to everybody. I hope it was informative for you all.
Merci, Vincent.
Thank you.
Could you add me for the certification? Sorry.
Which name was that?
Maxime Daniel.
I do not, but I will now.
It's okay?
Also, and Daniel,
Great,
please.
thanks.
Thank
And
you.
Daniel, yep.
Thank
got
you.
it. You're welcome.
Lisa Boyd Algae,
Got it. Boyd.
Algae, ALGEE.
Thank you. I've got that.
Thank you.
No
Okay.
problem.
Can you add Alain Courtemanche?
Yes, I can. Thank
Great.
you.
Bye.
Bye-bye. Thank you, Vincent.
So could you could hear me okay?
Yeah, it worked really well. I could hear you in your videos. We could hear them too.
Okay, great.
Yeah, it was good.
Okay, well, thanks. Any
Thank
feedback, send them my way. Okay,
I
thanks,
will.
everybody.
Thank you.
Hey, thanks, Vincent. That was very good.
Bye.